All right. This could be. No, I think you're missing the point. The recordings are available on the YouTube channel. So you're not going to get it on your mails. You just have to go to the channel which has been mentioned in the last sessions. So you should be able to see it there, and it all makes sense.
You are not audible.
I'm so sorry. I was on mute. Let's talk about, uh, let's begin the session with networking. We will be talking about the networking components, what are the basic components in networking, how do you configure it quickly, and how also to set up a virtual machine on AWS. So to start with the basic networking concept, we do have um, classes of IP address. So let me just pull up some networking videos quickly. Sorry, networking slides, which will quickly help us go through it. Okay. Sorry, 1 second. Just give me 1 second. Okay, so basically, the basic networking, if you see, I just want to quickly make you understand. There are three important components, right? One is the PC, the next is the switch, the next is the router. Okay, and then what does a PC do? It's the place where the data is generated, and it's the PC who's going to receive the data. How is it done? With the help of addressing technique called as IP address. Okay, so understanding IP address is very important. And then the switch does the job of connecting two machines if they are in the same network, and router does the job of connecting two machines if they are in a different network. So this is very basic concept, and uh, the IP addressing itself is actually classified into these things. Okay, so class A is in this range, class B, class C, class D, and class E. So this is one part of it, and then this is also rewritten in this format, and there is another component in the which is the default subnet mask. So for class A, it is going to be 255.0.0.0. Class B, it is 255.255.0.0, and class C is going to be 255.255.0. So with these two combinations, or we can abbreviate this in terms of /8/16 and /24. So with these formulas, with the IP address, with the subnet mask, there is a technique where we can do an AND operation, which the PC does technically to find out what network they are in, which network they are in, and this is how the PC actually does the AND operations between these two to figure out whether they are in the same network or not. I'm not getting into too much of this, but then overall, if you see the summary of this, what happens is for a class A, okay, um, for a class A, there is default networking is the first byte. Okay, any IP address, if you see, has 4 bytes. For 1 byte is equal to 8 bit. Okay, 1 byte is equal to 8 bit, right? So class A is saying that the first byte is my network ID, the rest of the 3 bytes are my host ID. Okay, class B says that 2 bytes are my network ID, 2 byte my host ID. What does this mean? Which means any number. What is the number? And each byte can have a value from 0 to 255. So effectively it is 256. So any value. Now, why did this number come? Because it's a byte. And if you calculate 8 binaries, you convert it to a decimal, you will get 255. So, so eventually each number can have so many hosts, which means 2 to the power of 24 hosts. In class B, you can have like n number of hosts, and class C can have 3 bytes as the network part and 1 byte as the host. So keeping this in mind, let's take up this, and we will use a class B network, and then we will break that down further into a class C networks, right? So that is how we are going to use it for our practical session today. So just this is the conclusion. It's like the first octet in class A is the same, then which means both source and destination are in the same network. If not, they are in a different network, right? So in a class B, the first 2 octet has to be the same. So for it to be part of the source, I mean, they to be declared as source IP and destination IP. And class C is same for, if at all class C is same for both, which is the first 3 octets, then they are declared as the same network, right? If not, they are in the different network. So some of the examples is, if you see this, this is in class A, and for it to be, just to see for class A, only the first octet has to match, which means they are in a class A and they are in the same network. Okay, this is class C, okay, based on the thing. So the first 3 octet has to match, which means it is not matching, which means they are in a different network. So this is class B, which means the first 2 octet has to match, and then since they are matching, they are in the same network. So this is just an example. So that's the overall networking. So what we are going to use for our example is we will be using 172.18.0.0/16 as our main network, and this is our main network. And further, we are going to make this as smaller networks, which we will call it as sub networks. Okay. So we will stick to this example for today's session, and we will see how we can create the machines, play around with the machines and stuff. Excuse me here. Okay, So this is my AWS portal. I think we did see that in the previous session also when we were talking about security. So I'm going to go to VPC, right? And what we are going to do right now is set up something like this. Okay, before I set up, I have to walk you through certain things. Let me do that. But then what we should be doing today is this. Okay, so we will set up a VPC, then we will do subnet configuration. We will create an EC2 instance. We will log into this. We will try to understand what is this and what is region, right? So this is the demo which we will be going through. So yeah. Okay, let me just begin the slide from the beginning. There are a good amount of information there to walk you through. Okay, so AWS has basically 26 regions, okay, and 84 availability zones. Okay, what does this mean? Yeah. Okay, so availability zones are very much related with the regions. They are sub part of a region, and there are 14 local zones and wavelength zones. This is for ultra low latency applications, which means if a customer is looking for an application which should have very low latency within a country or a local, they do have a special use case. Apart from that, they have announced 8 regions and 33 local zones. They also have 2x more regions when compared to others. They are connected very well on these countries. They have direct connect options. This is a very interesting concept where it is a private connectivity, and this is like an extended edge points, like a region is there in one place. Like in India, Mumbai is the region, and Mumbai has like 3 availability zones that forms a region. Apart from that, we have around 6 or 7 point of presence. You understand? A point of presence is like a tiny data center trying to go as close as possible to the customer so that they can get connected to that region. Okay. So out of which 3 are in China, which are not accessible. China regions are basically not for us. They are basically only for Chinese people. This is decided by the China government. It's not decided by the AWS. Um, so the idea is they want to increase the local business, and this way they will be able to increase the utilization of the local AWS data centers, and due to which there'll be more servers, more power, more cooling requirement, which will increase the Chinese the local market business. So that's a pretty nice idea. And these are regions. Orange colors are region, and the number inside that is called as the availability zone. So if you see here right now, there's only one availability zone which has one region which has 6 availability zone, which is North Virginia. And this is the place where I did mention in the previous session, if you can recollect, that this is the region which will give you all the free service which AWS announces. Okay. Other regions may have, may not have, We cannot guarantee that, but this region, which has 6 availability zones, will definitely have, because they have dedicated 2 availability zones just for free services for the customers to try and get used to it. Okay, so India has another region coming up in Hyderabad, and this is become +1. So which means Mumbai region has 3 availability zones now. How is this region and availability zones linked together? So this is how something which is linked. So this is a region, if you see, and this region has 3 availability zones. 1, 2, 3. Um, so here, if you see, these 3 availability zones are interconnected. Okay, these connections are private connections. Please understand, they are private connections where AWS has dug the road, and they have laid cables, private cables, their own fiber cables, to get these 2 availability zones connected. So now what is the distance, ideal distance between these 2 availability zones? On an average, between 2 availability zones, the average distance is going to be from 30 to 50 miles, which is approximately 45 kilometers to around 85 kilometers, right? So they have designed it this way. Okay, they have dug the cables, they have made sure there is a connectivity. This is a pure AWS connectivity, right? It's a private connectivity. So now question is, if I have a virtual machine on this, and if I have a virtual machine in this, will they be able to communicate? Yes. Will there be any charges? Yes, there will be transactional charges. Okay. So while designing these things, we need to be very careful about these things. But this is a great feature. And these 3 availability zone put together showcase us, saying that this is a single region. Each availability zone is made up of multiple data center. What is a data center? Uh, Data center is a combination of network servers, to switch, storage, and power cooling, everything, right? So each has multiple such data centers. They are as close as possible, maybe 10 feet, 100 meters, 10 meters. It could be next building, the next road building. So that whole thing is called as an availability zone. They don't have to really disclose their actual location itself. Um, they don't have to make it really public. So this is the regions and availability zones. So each region has a minimum of 2 and a maximum of 6. But then on an average today, if you see, most of the regions has 3 availability zones, right? So a total we have seen, and each availability zone is interconnected with a high bandwidth. That is what I'm saying. We call it basically a backhaul link, and it could be in terabits per second. Okay, not giga. Okay, nowadays we get 1 gig speed at home, right? I'm talking about 20 bits per second, or 300 terabits per second connection between availability zones. That's a great stuff, right? We don't know. We really don't know what bandwidth they are maintaining. That's because that is completely private. It is within AWS, and they don't have to disclose that at all. Okay, but they have taken the permission. They have dug the road. That's their own cables. Now, why is AWS doing all these things? Why can't they just give it to any telecom provider, take the service from them? That's because they're thinking long term. They understand the business, and they purely have trust on the cloud business, saying this is going to grow because the demand for the customer is going to grow, and the customer really need this cloud way. So they really understand the business. They think long term, and that is why they started doing all these things, putting their own cable. Okay, is AWS first in the game to put all these private cables? No. Uh, there is another guy who actually started off with this concept. Previous to that, it was only telecom companies like Airtel or Vodafone or Verizon or AT&T. Those people will come and put the cables, right? Tata or Reliance. But then the concept as a company they started off is Google. Google has crazy amount of cables running around the world. They have their own fiber cables under the sea. Now, what is undersea cables? So between regions, even if you see AWS, between regions uh, which are over the seas, how are they connected? That can be connected only through undersea cables, and um, uh, laying those cables is not easy. Okay. Um, it is tough. Okay, say for example, you can lay a cable for 1 kilometer on the land, say within a day. Okay, if you have proper machineries, maybe in just a day, morning you dig it, and as you dig, you can just lay the cables. But that is not the case with the undersea. Undersea, somebody has to go deep dive, put it on the clamp it on the bed under the sea, make sure the cable doesn't move around, stretch around. There's no hard particle sitting on top of the cable which might cut. If you carefully see the cable itself, it is pretty interesting. You see this portion is only the fiber. Rest all this all thing is the protection layer. There is a immediate metal layer, then there is this part is like a semi plastic, and there's a hard plastic, there's a metal rods for cushioning action. So you can imagine that portion of cable, this cable can handle say 1 terabyte of connection. Okay, because each fiber can handle nowadays 8 to 16, and if you have like 100 cables in that, it is close to around 1 terabyte, right? So you can imagine this is a thin stuff, right? So it's not easy to handle things under the water, right? So this is not a new technology. Okay, this is a old technology. This has been there for a very long time, but only the telecom companies will have it for internet connectivity. And you might have heard saying that, hey, there was an earthquake, there was a fiber cut, there's an internet slow, which happened almost 5-6 years back. In fact, it happened in the last 15 years almost 2-3 times. So the internets were slow for a couple of days, almost for a week, sometimes for almost a month, because somebody has to go in, see where the cables are cut, route it through again, make sure the cables are not cut again. They have to lay extra cables, join the fibers within the water. It's not an easy task. Trust me, it's just not an easy task. So it needs really skilled laborers, highly paid laborers actually, but it needs a lot of time. We cannot just do it things all together. So that's pretty much on the overall view of AWS before we start off with the implementation. Let's see the networking part. So as a VPC, okay, let me just take you to the page itself. I'm going to change the region. The only reason is I'm full with the VPC. So there is a limit of VPCs for free account. For every region, there is going to be a limit of 5 VPCs. So I'm already running full on that region. Here we can kind of play around. Let me just delete one just to be on a safer side. Let's see. Delete option is there. So when I delete it, it is going to delete all the subcomponents. You see, it is saying deleting subnet, security group, blah, 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 which is linked with the VPC. Now, What is a VPC? VPC is the main networking component in AWS. Can I do without it? You may be able to get away, but if you are wanting to connect privately, and if you wanting to connect to a VPN, you will end up creating a VPC. Okay, so VPC is important, and I'm going to go back to my sheet, pick up saying so I'm going to put the VPC name. So VPC, we call this as CIDR, classless interdomain routing address. So if you see here the CIDR, we just created. We can also have IPv6. I'm not getting into that part. I'm just going to create it. So this is like the virtual router. If you can recollect the router diagram, which I just started off with today's session, that's a virtual router kind of thing, right? So VPC is your virtual router. Now I'm going to create virtual switches like the subnets. Okay, so so subnets. If you see, there are certain subnets. We will not get into that part. So we will just go with our VPC. It is saying you can create subnets in this CIDR. So I'm going to say webinar subnet 1. Now comes an interesting part. Yes, CIDR is there. I should be using this as per our thing 0.0/24. So there is one more component. It says no preferences, but it does have options. These are nothing but availability zones. Listen carefully. These are availability zones which are like the I can call it as the data centers, right? Individual data centers as such. So which means the subnet can be part of a single availability zone only. Okay, this is a critical configuration, right? So a subnet can be part of a single availability zone only and only, right? So does a VPC be part of a single availability zone? No, it is part of a region. That is why when we created a VPC, we were never asked for it. Okay, so I can create multiple subnets. I definitely need 2 subnets. So I'm going to create multiple subnets here itself, right? And then I'm going to put that in another availability zone. So what is the difference between these availability zone? Is there a performance difference? No, these are identical, just that it gives us the flexibility to create a high availability in our environment. Okay, so I can have one machine in one subnet, another machine in another subnet of the same purpose. And even if worst case one availability zone of AWS dies or it goes not reachable, my service is not stopped. Okay, I'm just going to create it. So we have done. Let me go back to the PPT. Let me go to the slide which I just showed you. So if I go to the slide, so we are done with VPC. We are done with subnets. Okay. So the next thing is we have to create an internet gateway. Before that, we will check. Excuse me. So these are routing tables. Okay. So the other two components is internet gateway and route tables. Okay. So now we are partially ready. Okay. When you create a VPC, there is multiple components which gets created. Let's go through it. Right. So the first thing is the VPC ID itself, which is unique actually across the AWS, across all the accounts, all the regions of AWS. This number is unique. Okay, that is why, that is how you can call back the um, uh, you can call back the support team and say, hey, I have an issue with my VPC, and they'll be able to immediately identify because this number is unique. Second thing is it assigns a DHCP option set. This is nothing but an option to say how the IP addresses should be allocated, who should handle it. So we have not selected this, which means this is by default handled by the AWS. We could play around with this. Okay, we do have the CIDR, the tenancy is default, and we have the main route table. The route table is one of the core components of AWS, right? So as a router, you need to have a routing table, and that is also maintained virtually. Okay, so without a routing table, the router is not complete. Okay, so also there is an access list. So there is a default access list which is created, network access list. There's a default route table which is created. I'm not getting into the access list as such, but we will definitely get into the route table. We are more interested in this. We will definitely get into the route table. So getting to the route table, let's try to understand what is this route table for this particular VPC, right? Our webinar VPC. It does says first thing is it is a main route table. Yes. So what does this main route table mean? A main route table in the sense, this is the default main route table for this VPC. Can I delete it? No, you cannot delete it. You see that? Cannot be deleted. Can I create another route table in this VPC? Yes. Can I make that as a main route table? Yes. Okay, you can play around with that, right? So now what is there in this route table? We have routes, and this is very interesting. This routes says this is the destination. No, you cannot detach a main route table. So these are the routes. These are the routes which are available, which means any machine who wants to go out of the system, okay, or who wants to go out and talk on the internet, they should go through this route table. And right now this route table says the only outbound network which I know is the VPC itself. I don't know anybody else. So if I have an EC2 instance, a virtual machine basically, and if I somehow log into that and try to ping yahoo.com, it will drop off because this gateway is not, I mean, the internet traffic is not there. Now, interestingly, how does the internet traffic work? We need to edit and add an internet route. For that, I need to create an internet gateway. Okay, so I'm going to create my internet gateway. There's absolutely nothing. This is just a logical component, and then we need to attach this to a VPC. Okay, you can have only one internet gateway per VPC. That is enough. It is a virtual concept. There is no limit on the bandwidth. There's nothing there, right? You can just attach one internet gateway. Okay. Now go to the route table. Let's go to our route table, which is this, and edit. Now add internet gateway, the one which we just created. And now what should I add here? I should add this. And what is this? This means all traffic. Okay, this is the IP address world. This means all traffic. So let's save changes. And now my VPC is ready. My VPC is ready. What are the 4 components which we saw? Let me just recap quickly. The VPC itself, okay, we did go through the VPC. Okay, we created a VPC. We created 2 subnets for that. Okay. You can create n number of subnets based on the count which you want, based on what is the size of the subnet which you want. Say, for example, the size of the subnet is 251 IPs per this subnet. So there is a pretty much subnetting concept which you can do, which will give you more details of how many things based on the customer requirement. So give me a second. Okay, so we have the internet gateway and we have the route table. Cool. We have most of the things up and running. And the next thing is we need to create a EC2 instance. Interesting. So let's go with this. So I'm going to create, I'm going to leave this pages there for our reference. We'll come back to this. So I'm going to create another. Let me just open up a new tab. And I'll go to EC2. Guys, just give me a minute. I'm just getting cough continuously. Give me just 1 minute, okay? Right. Thank you. So let's create a instance. Okay, let's first delete these two instances. Okay, let's create this instance. So creating an instance is nothing but the service name is called as EC2. Okay, so EC2 is basically an virtual machine. Elastic Cloud Compute is basically a virtual machine, right? So the first thing which you select, the most important and the critical component which you select is your image. Image is nothing but it consists of your um, OS, whatever components you want to install, right? Say, for example, in this, it says Amazon Linux with 5-year support. It provides kernel, and these are the softwares which are installed. And if you come down, there are other tools which will say I have more options like these are the installs. So these are ready-made OS. Okay, images are nothing but a ready-made OS. So you can, I mean, AWS has created n number of images, right? So there is also something called as marketplace. This is pretty different. It's completely different from the plain simple image. This is like allowing third-party vendors, like Juniper is a third party, okay? And Junipers are good with firewalls, routers, right? So they have a virtual firewall, okay? So this virtual firewall will get created as a virtual machine, right? Cisco firewall is there, okay? So Barracuda firewall is there. So VPNs are there, virtual VPNs. You can just play around with it. You can create n number of scenarios. You can easily play around with it a lot. Apart from this, we have community AMI, wherein we say the operating systems and the different types of operating systems, and you can select anything. Even Windows, there's a lot of options in Windows. Licensing is not provided by AWS for Windows. Even for Red Hat license, you have to go back to the Red Hat. So AWS is not getting into the licensing part. They'll just provide you plain simple image. So if you see, they have a ready image. Each image is a size of like 8 GB, 10 GB, 20 GB. It's the size of the operating system, okay, base. So you can imagine how much space they have invested. I'm talking about close to around, I don't know, 8 GB, 10 GB if you talk about. You can calculate this easily. 10 GB into this number, around 1000 terabyte, 1 petabyte. 1 petabyte of storage, 1000 terabyte, okay? 1 million gigabyte, 1 million gigabyte, okay? And that's called so many space, so much of space is allocated just to store the images for the benefit of the customer. 1 petabyte of data, just there's no revenue for AWS. There, it is just sitting. And this is not just sitting in one data center. It is this data is supposed to be there in every region for the customer to select. So why I'm saying all these things, you can imagine the amount of investment which is coming through. Okay, storage capacity, you cannot even imagine the data storage capacity which the cloud vendors have, right? It is crazy. I would say it is in zettabytes, above petabytes. 1000 petabytes is 1 zettabyte, so it is in zettabytes, right? So, okay, just to give you one glimpse, the one of the data center, one of the availability zone, the cost of one of the availability zone is 1 billion. There is one big availability zone out of the 84. The cost of one availability zone itself is 1 billion. So you can imagine the amount of money which is invested there and the revenue which they are generating out of it. Right? It's crazy, right? I'm just trying to say all these things just to make you understand cloud is big, cloud is the future, and no customer is going to go out of the cloud. But now, is the cloud the only solution for the customer? No, it's going to be a hybrid solution. But cloud is going to play at least a 40-45% major role or major configuration in every customer's data center. So that's like almost 40 to 50% of the customers' stuff is going to be on the cloud. Okay, so I'm going to select the default. This is the free tier. Always look for free tier so that you're not charged, because this is basically free. You'll not be charged for using the image. Anything else, you will end up getting charged. Even though you have selected a basic account to create it, you will at end of the day get charged if you're not selecting the right thing. So I'm going to select this, go next. Now comes the instance type. Okay, instance type is basically what kind of instance do you want to select? Okay, there are families. Okay, majorly, if you see, the families are divided into categories, right? This is general purpose. Anything starts with T. This is general purpose. T2 is an old one. T3 is a new one. And T3A has a different meaning, which means A is for AMD. So these are Intel-based processors. These are AMD-based processors. Okay, so you know there are two different kinds of motherboard. And if you see C4, C is for compute, which means it's going to give more preference to the compute when compared to here. It is 1:4 ratio. Here you will see 1:2 ratio. You see this 4 CPU, 7.5 GB RAM. Here within general, it is 2 CPU, 8 GB RAM, 1:4 ratio, right? Similarly, if you C is always compute, C4 is old generation, C5 is middle generation, C6 is the latest generation. Again, in C we have C5A, where again we have now the category. Give me a second. Right. So C5A, again AMD, but it starts with large. Okay, so the large is nothing but 2 CPUs. That is like a predefined. X large, 2X large, 3X, 4X large, 8X large, 12X, and 16X, and 24X. So each category will have maximum of 8 subcategories or 7 subcategories, not more than that, right? If you see here, C5AD, AD is nothing but you also get an extra local disk. Okay, so okay, I I think I have to reduce the intensity of my voice. I just want to showcase one thing. If you see here, this is particular heavy size 128 CPUs, 4 terabyte of RAM, Why I'm showcasing this is you can imagine AWS is gone infrastructure wise. Okay, this is like an infrastructure as a service. Infrastructure wise, AWS is the only person or only cloud which is so strong that it can give you any kind of combinations, any kind of granularity. Now, no cloud vendor, including AWS, will give you an option to select CPU and memory like a value. You cannot select 3 CPUs, 6 GB RAM, 5 GB RAM, or anything like that. Okay, so you can only select out of which, and I think they have a good category where you can select the closest of it. Okay, so I'm going to select T2 Micro. The reason is it is free of cost. Azure does has capacity, but I don't see this granular level of segregation. If you see the category wise itself, there are close to around, you can imagine around 10, 20, 30, 40, 50, 60, 70, 80 categories. Okay, and each category has 8 subcategories, right? So you can imagine there is a huge amount of 80 into 8, 640 options which you have, right? Permutation combinations. It's great. It's humongous, right? And this is all created based on the customer demand. Certain categories are old, C4 large, C1 is there. That's because there are certain customers saying, hey, I still need that category, which means they have to maintain that server, which they are running on that, right? A category is nothing but a group of servers configured in that manner. Think in the perspective of the cloud vendor itself, right? The cloud, the guy who's providing the service itself. Now we have selected T2 Micro, which is free of cost. How much it is free? You can run one machine for 720 hours. I repeat, you can run one machine for 720 hours. So much is free. Okay, for a month, basically. So I'm going to say next. This is an important page to go through. So we can have n number of machines created, say 120. Personally, I have tried 200 machines on my free account. At least it does create it. Yeah, to delete it, it took me some time. It was a little pain, but then just to do a random test, 200 machines was perfectly working fine. So I'm going to select my VPC. Now, where is my VPC? Okay, I'm in the wrong region. I'm going to go to the right region. Let me start over again. How did I find out I'm in the wrong region? Because the VPC which I named was not listed. So immediately I understood that it's in a different region. Okay. So which is a clear indication that if you create a VPC in one region, it's not going to be visible on the other region. So I'm going to select, there's an AMI ID which will be different for every region. And I'm going to select this. Now my webinar VPC would be visible. So I'm going to select a subnet. Now this brings to us, this selection brings us to us with one understanding. That is, remember, EC2 instance is going to be part of that particular subnet. And in turn, the subnet is part of a specific availability zone, which means the EC2 instance which you're creating is going to be part of that availability zone. Also, when you create a EC2 instance, there's a storage which is allocated for storing the operating system that is also going to be part of the same availability zone. That is what it means. So the subnet selection is just not for networking. It is also making sure that you are going to be selecting that particular availability zone, which is an important stuff. Now, this is another important thing. If I keep it disabled for today's session, then I will not be able to log into this machine, which I'm creating. So I'll keep this enabled so that I get a public IP. So in the IP address world, there are two kinds of IP. There is private IP and there is public IP. The reason these two have existed, just because we ran out of IP address. Just to give you a calculation, the IPv4 address, which we are currently using, is 32-bit. So 2 power 32 is 4 billion. And if you know, I don't know whether anybody has researched, basically in today's world, the overall count of all the systems in the world who's on internet right now at any given point of time is around 25 billion, which means it's a clear indication that 4 billion would not do the magic. So this was predicted almost 30 years back. They understood that this is an issue which is going to come up. So they, in the sense, whoever is managing this network stuff as a IANA body, they introduce a concept called as private and public network. And there is a way to communicate between private and public network. And the idea behind private network is anybody can use it within the organization. It's going to be local. And if you want to go to the internet and talk to any of the machines or IP address or any websites, you need to have a public IP. So you don't have to have n number of public IPs equivalent to the number of machine which you have in your house. So for example, everybody has a broadband connection. So in your at home, you might have like 10 devices, 5 mobiles, 5 laptops, all connected to a single broadband router. But end of the day, you have only one public IP, and rest all the device gets a private IP. So the router manages the transition between this private IP to public IP. Same thing here. Same thing here. What really happens is the machine, the Ec2 instance which we are creating, does get a private IP, which is constant. But here, in our example, every Ec2 instance will get one public IP. That's called one-to-one mapping, and the public IP will be maintained by the VPC. So when I enable this, it's an auto-assigned public IP. I don't have control over it. It's automatically assigned by AWS. So the further options are, I'm going to the main parts. I'm just skipping certain things. When you shut down the machine, what do you want to do? Okay, there's an option to shut down. You can log into the machine. You can say, for example, Windows, you say shut down. You want to terminate it. So what's the difference between stop and terminate? You stop is like to stop it, terminate is just going to delete it off, right? You can enable protection, terminate protection. So accidentally you don't terminate the machine itself, right? So you can also say, yeah, this is pretty much which I wanted to showcase for now. Tenancy. Okay. So here the next option is storage. Interesting factor. So storage. This is what I said. Did we select the storage anytime? No, but there is a root partition which is selected. This is your, in Windows, we can call it a C drive. Right now, I have selected a Linux machine. We could also select a Windows machine, and this predefined GB will be 30 GB. This is the snapshot name, which is having the image. The image, actually, the AMI which we selected has is linked to a snapshot image, and this is actually containing the operating system. So this image is going to be written in this volume which is getting attached to this EC2 instance. So there is an 8 GB volume, and the volume is going to have this content of this image, which is nothing but the Linux operating system. Okay, there are different volume types. You can get, I mean, it's pretty interesting to go through. There are certain IOPS concepts. This is how we measure the speed of the storage. IOPS is nothing but input output per second. Okay, and when you say delete on termination, when I delete a EC2 instance, I am authorizing AWS, please delete this volume also, which means I can also untick this. When I delete an EC2 instance, I can say only delete the compute part, keep the storage part. So I have the flexibility of it, right? And I can also encrypt it. Next. Tagging is another very important concept. This is how the industry is able to identify the machines for within their business. And then we have the security group. Security group is something which is going to allow the traffic for that particular EC2 instance for in and out of the traffic. I repeat, security group is the one which is going to allow the traffic in and out of the traffic. Okay, so basically, if you see, I'm just allowing SSH. SSH is nothing but your way to access the Linux machines. Instead of creating, I can also select which is there, but that's not there what I want. So I'm going to go give a name SSH only. So I know this is the name, right? This is inbound connection. I'm saying all traffic. Now I'm going to review this and launch it. Now, one question is, did we create or assign any username password till now? No. Where is it all? For any machine to access, there should be a username and password. We have not given anything as such as a username and password. Where did it go? Okay. Every image which you create has a username. I repeat, every image which you create has a predefined username. Okay, so fine. Now, what about the password? The password, when you click on launch, there is a pop-up which comes says, hey, can you create a new key? I'm going to create a new key. Okay, ideally, I do have existing key. I could use that, but no, I wanted to showcase how the key works. So this is a public and a private key concept. It is not your normal password you type in for 8 characters or 10 characters. The reason is this public and private key concept is created because the private key is a 2048-bit key. I repeat, RSA key is a 2048-bit key, bit. Okay, so what is bit? Why 2048 bit? Which means it becomes very tough for the hackers to hack into my machine, even if they get hold of this by mistake. Okay, so what's the issue with just allowing the local password? What is the length of the password you can keep? Max to max, and a very good administrator I have seen, they can keep up to around 18 characters. 18 characters. In each character, let's assume that it is 1 byte, 8-bit. When you convert a character, any alphanumeric character into binary, you may have 8-bit, which means even if you keep it 20 into 8 is 160-bit. I am right now talking about 2048-bit, which is pretty strong, right? It is almost 15 times stronger than the strongest password which you usually an administrator creates, right? Which is great, and this is the right way of doing things. So can I override this later? Yes, you can log into the machine, you can enable local login, you can enable local passwords, you can ignore the keys, you can do anything because this machine is yours and you have full rights on this and you can do anything. Now, important factor. When I click on download, it's all done. You can read through. I can pause the whole thing for 30 seconds. You can read through. AWS does not store this key in their system. This is a private key. They store only the public key because when you create a machine and you say, I want to select this key, it will put that public key into that machine. It's like you have one key and n number of locks. Okay, you just lock the door with the similar kind of a lock wherein you can open with the same key, right? Think of that way. So anytime you get a new door to your house, you are using the lock for which you already have the key, which means for you it becomes a single key. And yeah, danger part is if somebody gets hold of that key, you are in mess. But then for you, it's like a single key, right? If you take a bike, you have 4 or 5 locks. All the locks can open just with a single key. That's how it is, right? So AWS will put the lock, which is the public key, on the machines every time when you select that. I'm going to launch it. I have the key and I'm ready to access this. Now, how do I access this? Okay, let's give it a minute here. It's still in pending state. Before we log in, we'll just go through certain components. What is this? Why this and stuff. Now, let's get into the machine. So there is an unique identifier which is created again. This is unique across your AWS account, across all the regions. Next, IP address. You see this? There is a public IP address which is automatically thrown by AWS. I don't have control over this, but I did have control over this because this is something which we assigned on a subnet. So it has taken one IP address from the first subnet. That's because we selected the first subnet. Great. If we had not selected auto assign public IP, this would not come. If this doesn't come, there is no way we can connect it. It's still in pending state, which means it is coming. Usually comes us pretty fast. Yeah, it's running. So the next thing is there is a public DNS name. So this is a private DNS name. Yeah, IP address, and there's a private DNS name. There's a public DNS name which is missing. There is a reason behind that. That's because there's an option on VPC which we have not enabled, due to which the DNS name, which could be automatically created by AWS, is missing. It's okay. Instance type which we selected, VPC which we selected, subnet, you can see the name which we selected. Apart from that, we do have more details here. Platform, AMI name, ID, okay. It's a Linux machine. Starter time, key name, saying that which is a public key. AMI location, who's the owner? This is my account number. I mean AWS account number, not my bank account number. So and then we have some reservations and blah blah blah. HVM. This is the HVM is like hypervisor virtual machine, right? The virtualization type. So apart from that, we do have security. It does say that it is part of the security group, the name of it, and it is saying what has been allowed inbound. Inbound is traffic coming towards the EC2. Outbound is traffic going outside the EC2. It says all traffic is allowed. Inbound, only so much is allowed. Networking, Same thing which is there in the summary, and it is also saying what availability zone to A. Can I move this machine automatically to 2B? No, you cannot change. Can I change the subnet after I have created the EC2 instance? Not directly. There are 2-3 steps which you need to do before you can do that. Storage, you can add more storage on the fly, no problem at all. Yeah, these are the default storage. Can I delete the default storage which is attached, the volume? No. This is called as EBS, Elastic Block Service. Status check, interesting factor. This is something which you need to understand is AWS created something, this is status check for customers understanding. Systems check says system is all good. Instance check says networking component is all good, right? It does take almost 2-3 minutes to come up and say all good. You have monitoring and stuff. Great. Let's log in. So I'm going to use Putty, a very famous tool to do SSH. But then this key is in PEM format. Putty doesn't like it. So ideally, we need to go to Putty Gen. And this is Putty Gen. We are going to load that. Where is that? Yeah, we're going to load this up and save this. I don't want any password. So I'm going to save it with a similar name. But then just that I'm going to remove .pem and save it up. So I have the PEM file. So right now I'm ready to rock and roll. Now, where is the username? We said the username is created automatically, but we've still not seen the username. The username is available here. Okay. When you click on connect, this is the username. Okay. If you click, it will disappear. So don't click. Or if you want to copy, you can go to SSH client. So you can copy this. So this is if somebody is using Mac. If you guys want to try, you can just copy the whole thing. Make sure this file, PEM file, is in that folder where you're trying. And for now, for me, this is enough. Okay. Where is my putty? I'm going to copy this. I'm going to download, select this, the key which we have selected. I'm going to connection SSH auth. Let's see, open. So I do get this message. Okay. If I am getting this message, which means that one important factor is my VPC is good. My VPC has internet access. I'm going to accept it, and I've logged in. All right, I'm going to take up questions. I do have another topic to finish, which is migrations. But before going to that, I would like to take up the questions, probably which will make sense. Let me see if I have any questions in the sheet. No questions in the sheet. So I guess everybody is good. Everybody has understood things, which is great. Cool. Okay, going further. So this is how you log into an EC2 instance, and then you can play around with this and do it. So I'm going to exit this. I'm going to terminate this. So here we have different options. We can stop. We can, yes, you can. But to do that, you need to stop the instance. And then you can go increase the instance type. This change instance types will get activated once it is stopped. Right now it is stopping. Say, for example, this machine is already stopped. I can just go, see this, change instance type, right? So you can always change the instance type from whatever you want. So that's pretty much possible. Pretty flexible, actually. You cannot do it on the fly. I mean, that's not an issue with AWS. It's the operating system issue. It doesn't detect if you do it on the fly. So cloud providers have not given that stuff. That is tough, Dipendra. I cannot bring Azure cloud comparison. That becomes a little longer session, which we cannot offer right now. So, but my understanding is I've worked on Azure as well. Components are pretty similar. You call it EC2, we call that VM there. So we call it as VPC, or we call it's VNet there. So yeah, I mean, I cannot show you practically. It's not feasible. But then concepts are very similar. Of course, it has to be similar. It cannot just be something new, because if it is completely new and customer is not able to compare, everybody is going to be in trouble. In fact, for your own interest, you should go search for AWS versus Azure versus GCP resources. You will get a nice comparison sheet as an image. It's nice. Somebody has listed around 20-30 comparisons for you to understand what service is what. It's interesting, basically. Okay, moving on, assuming that there's that's all is the doubts. The next thing which I wanted to touch base on is migrations. I'm going to show you, first of all, what is migration, what are the different types of migrations which you can think for. And let's see. So one of the migration is an offline migration, which is called as Snowball. Yeah, there is a snow family, which is called a Snowball, right? So a Snowball is basically an offline migration. You get snow cone, snowball, and snowmobile. So what is this? Let's quickly talk about this. So AWS snow cone. I just want to show you the images. Snow cone is a small device. This is the size of the device, just to give you a comparison. This is a small device, but it does have a decent capacity of 8 terabyte. So when you book this, okay, AWS is going to ship it to your address, basically your corporate address where the data center is. You can put 8 terabyte of data into this and ship it back to AWS. They will put it in the storage account of storage space of your AWS account. But now the only challenge there, or only thing which you need to take care is, it is within that region. Like in your data center has to be in India if you want to put the data in India region. Okay, so Snow Cone has a capacity of 8 terabyte or a maximum 16 terabyte, but Snowball has a bigger capacity. It looks big a little bit, and you see this is the size of it, and it's really solid, rock solid. Okay, so the way it is you create a job. The AWS is going to send you this box, connect this box to your local data center, copy it, copy the data, and then send it to AWS. It is going to put the data in S3 bucket. So that's your space in your account, which your data from your data center is going to go there. It's a very interesting concept because now, is this the only way I can move the data to AWS? No, you can move it online. If you have a data like your Google Drive, you can upload it from your system. You can also upload it to S3 bucket. Basically, that's a service. Now, who would prefer for this? If somebody really quickly needs things, they don't have a proper internet, and they really want to make it very, very quick. So that is where they will come and say, "Hey, send me the box. I'll push the data, and then uh, we can have it quickly on the S3 bucket." Okay. So this box is rough and tough, and it also has a return shipping address. So as soon as it comes, you just need to flip this address and it can go back. That's now what is Snow Mobile? That's an interesting part which I wanted to showcase. Snow Mobile is basically a truck, literally a truck. Okay. So this was introduced from 2016. So when you book this, which means you have petabyte of data, 100 petabyte of data. The capacity of the truck is around 10 petabytes, and you probably want to move 10 petabytes of data. It's nothing but the box which you saw, Snowball. It's like a collection of 100 boxes, which has become a truck, and they made sure that truck has an option. It gets plugged in. It stays there for a week until all your data is moved inside the truck, and it is going to ship it to the nearest data center. It's like a walking data center. It's a data transfer stuff. So you can imagine how serious is this business. People have gone beyond our thought process. They have gone crazily beyond our thought process. So and this works. This perfectly works, and there's a big demand which is going on, and consumers are consuming it. Okay, so this is one way of offline migration. Okay, I have a question. It's okay, let me pick it up. The EC2 instance created on VPC subnet is running by its own internet connectivity. No, or it needs connectivity from physical PC. Where is the physical PC coming into picture? My EC2 instance is running on the cloud. I am not running it on my PC. If I shut down my PC, my EC2 instance is still running there. My PC and EC2 instance doesn't have any connectivity, or doesn't have any dependency. I can log into that EC2 instance from my PC. That's all. But I really don't control. I mean, it's not that EC2 instance is running on the hardware provided by AWS. I don't. Does it make sense? Why is this? Okay. Now, what are the other options for migrations? We do have S3 buckets, right? We can just upload data. How much data you can upload? You could, okay, just give me a minute here. All right. So the S3 buckets, we can just create buckets and we can start uploading. This is another way of data migration. So I can just upload like 10 GB, 80 GB. One shot I can upload up to like 80 GB of data. We were talking in terabytes in the previous topic. Right now we're talking in gigabytes, which is 1,000 times less of it. Right? So there are limitations. So over the internet, I can upload n number of data. I can go up to 5 terabyte, 10 terabyte, but I have to slowly do it, right? So if I have a good speed of bandwidth, internet bandwidth, I can keep uploading into this, no problem at all, right? So this is one way of migrating. The other way of migrating is we can create storage accounts to do a private migrations. So this is like on-prem access to virtually unlimited cloud storage. So storage gateway is an option where you can extend this S3 bucket privately into the customer's data center for a private movement of data. Okay, whatever we just showed as, I mean, we saw that as the S3 bucket, it's a public, through the public it is getting transferred, but storage gateway is a private way of doing things. So this is an overall view on the data migration things. Yeah, so, okay. Data sync, which is actually the EFS part of it. Data sync is more like the data which is there on your local data center will go into EFS. So this is another component, which is a file system. If you have heard about sharing one server between multiple virtual machines, yeah, I'm sure you guys have heard saying that you can have a NAS storage in your home. Yeah, NFS, that is right. So so you can have a NAS storage at home. 10 people can share it. A similar kind of a concept, which is having unlimited storage, and your data sync we can set up a data sync from your local data center to sync up the data to this EFS machine. And in turn, this EFS will be connected to the EC2 instances. So that's like the system where you get the whole data transfers. So that's an overall migration topics which I really wanted to touch base and show you how the networking is, how the virtual machines are, and how the systems are. Open for the questions. So there is a feedback link. Not specifically on the DevOps itself. Currently not planned anything, but we'll keep you posted. We have more to come on the webinars. We will keep you posted on that. All right. I hope today's webinar was informative, and I hope it helps you understand things much better. And you should be able to start. You should start enrolling into the certification course to understand better, which will give you a great idea, hands-on experience, labs, which is a great stuff. All right. Okay. No questions. So yes, I did cover yesterday's and today's session together. We did majorly yesterday's session, and I did cover up today's session as well. So I kind of merged both the sessions stuff. No, there is no sessions tomorrow. Um, that's a good question. Yes, we do have the trainers. One of the sessions I would be doing it, Ramnesh. Uh, and you can also click on that link for the full course, which is also provided. Yes, Satish, the free workshop is completed. That is right. Thanks.